Good morning, class. Welcome to the physics online classes of class 9th. Today, we will learn a new chapter which is named Gravitation. It is the 10th chapter according to your NCERT book, and if you look at the refresher, it is the 3rd chapter which is named Gravitation. According to the name itself, it is clear that we will learn about gravitational force or the gravitation which is acting due to the planet Earth. So, let's start the chapter. We have already learned in the previous chapter that whenever a body moves, some force is applied on it. Or in other words, we can say that a force is necessary to make a body move. So even whenever a body is in motion, the force is applied on it. We can say some external force is acting on the body to make it in a motion. We will see some other examples in daily life. From the picture itself, it is clear that some apple is falling from the tree. In what direction is it falling? It is falling in downward direction. Okay, we will see the figure 2. Here also the rain is falling from the sky but in downward direction. So what these figures tell us? That whenever a body is dropped or if it is tossed upwards, then whatever the body's motion is, but will come back in the downward direction. What it means? That some force is acting in the downward direction on that body. And what that force is doing? It is pulling that body towards the earth. So from here it is clear that the earth is exerting some pressure or a force which is attracting the body towards itself. So maybe it is a force of attraction. Right, it is a force of attraction which is named as gravity. So earth is exerting some force of attraction on that body due to which it is pulled towards it downwards. Okay, and this force of attraction which is allowing the body to come in the downward direction is the gravitational force of the earth. So let us see the examples. Already we have seen that any body which is coming downwards is due to the gravitation. Now any other example, like if it tossed a single object to upward direction, after some velocity it will come back to downwards. What does it mean? Means some external pressure which is gravitational attraction is pulling that object towards the earth, that is towards the center of the earth. Means the force is acting is towards its center, means the gravitational force is a central force. So what it is doing? It is pulling the object towards itself. It is called the gravitational force of earth or gravity. Now the gravitational force of earth is the force which is trying to pull the object towards it. So the two properties which we can tell about the gravitational force is that gravitational force is a force of attraction, right? Because it is attracting the object and pulling it downwards to the center of the earth. So it is a central force. Now we will clear it that it is denoted by the letter capital G. Now we will see that gravitational force of earth is responsible for many things which are happening in our earth. The first example, the gravitational force of earth is responsible for holding the atmosphere above the earth. From the figure itself, it is clear that the rain falling from the sky is always in the downward direction and it is falling to the earth, or the flow of the water in the rivers. These are the examples where we can see the force of attraction that is acting from the center of the earth, which is the gravitational force. So every object in the universe is attracts to every other object, right? So we will see now what is the law of gravitation tells us about. As every object in the universe is attracted towards each other. What does it mean? The force with which two objects attract each other is the gravitational force, and they attract each other with certain force, right? If the masses of the bodies are small, then the gravitational force between them is very small, and if some of the object becomes large, then the force experience will also be large. So let us see what this attraction of the force between the two objects will tell about. We have already discussed that the universal law of gravitation means gravitational force is a universal law. Why? Because it is acting throughout the universe, right? Now, what is this universal law of gravitation? Firstly, according to Newton, whenever a body falls, it falls downwards due to the center of the gravity or the gravitational force of the earth. Now, if two bodies are present, they also combine a force of attraction on each other. So, on basis of this, Newton gave a universal law of gravitation, according to which every body in the universe attract every other body with a force. Now, this force be F. Let us consider the force acting on the bodies be F. Now, the force between the two bodies will depend on the mass of the bodies, right? Now only we have studied if the mass of the object is small, then the gravitational force will also be small, and if the object's mass is increasing or having a large mass, then the gravitational force also become very large. So it depends on the mass. So first, it is clear that the force between the two bodies is directly proportional to the product of their masses. From the figure itself, it is clear that we are considering two objects of mass m1 and m2, and the distance between these two objects is r. So what the Newton's law or the universal law of gravitation is telling about? The first thing which we consider will be the force acting on the two bodies is directly proportional to the product of their masses. So we already considered the force of attraction Bf, then F will be directly proportional to m1 and m2, which means the product of the masses. Secondly, the force between the two bodies is inversely proportional to the square of distance between them. What is the distance between these two objects? It is r. And what is the square of the distance? It will be r square. And what the word inversely proportional means? That it will be equal to the reciprocal of the square of the distance. So it is given as F is directly proportional to r square. So these two equations, let us consider equation 1 and equation 2. From combining these two equations, we will get the force of gravitation or the law of gravitation or the universal law of gravitation. Now, by combining these two equations, we get force is directly proportional to m1 into m2 upon r square. Now, when we take out this proportionality sign, some constant will come. So, here the constant will be g, which shows what it is. It is known as universal gravitational constant. So, here we will take out the value of g. Now, universal gravitational constant g will be what? Now, gravitational constant g, how can we show that value? If we will take out the value of g, then r square will go cross to the f and the m1 m2 will be reciprocal. So, the value of g may be written as f into r square upon m1 m2. So, it is the expression for the gravitation, that is universal gravitation constant capital G. Now, we will see the units of gravitation constant. Here we know that the unit of F is Newton because it is the unit of force. Here we are telling about the force acting on the objects. So, F will be also the unit of Newton. Now, what is R? It is the distance between the two objects. Since it is distance, it will be measured in the terms of meter. But here it is R square. So, it will be unit is meter square. And at the downward, what it is written there? Product of masses, that is m1 into m2. Now m1 into m2, two masses are there, so it will be kg square. So the unit will be Newton meter square per kg square. You can see here in terms, we will write the word for Newton n, for meter m, and for kg it will be k and g. So here we can tell the unit of gravitational constant. I think that you have got this right. So move forward. So before seeing this, what you have imagined, this is the solar system of our earth. We know that in our solar system there are 8 planets, and what these 8 planets do, they revolve around the sun. And what they revolve around, they are revolving in the orbits and they are revolving around the sun in the particular object. What does it mean? That some gravitational force is acting between sun and the earth, which keeps the earth in uniform circular motion around the sun. Yes, it is the gravitational force which is acting on the earth, which makes the earth to revolve around a uniform circular motion around the sun. Similarly, we can see where it is Earth and the Moon, where the Earth, due to Earth's gravitation, Moon is revolving around the Earth. So it is the gravitation of the Earth which is acting on the Moon and letting the Moon to revolve around the Earth at uniform speed around the Earth. So we can say that gravitational force is responsible for the existence of our solar system. Yes, our existence of solar system can give a hold of gravitational force which is acting on the planets and letting them to revolve in an orbit, and it is acting on the moon which is enabling the moon to revolve around our earth. So gravitational force holds the solar system together. Have you got it, children? So move to the next topic. Here, the planetary motion. What these planets are doing? These planets are doing motion which is revolving around the sun and they're moving in the particular orbits. Now only we have studied that the solar system, the planets are moving due to a particular force which is the gravitational force. By seeing this planetary motion, Kepler gives some law for what these planets are moving and what orbits they are moving. So these laws of motions are said to be Kepler's law of motion. Okay, now we will see the Kepler's law of motion. He tells the three laws, he stated it about the planetary motion. What this law states? See, the first law of planetary motion states that you can see the figure 15 through which we can tell the first law of Kepler's. Now, Kepler's first law of planetary motion tells us that the planet always moves around the sun in an elliptical orbit, with the sun at one of the foci of the elliptical orbit. Means, which is the focus? It is sun, around which the planets are moving, but they are moving in particular orbit which is in the shape of ellipse. So we are saying that planets are moving in an elliptical orbit. So the first law states the path of the planet around the sun, which is a oval shape, but we think that the circular motion used to be done by the planet, so maybe the orbit is circular, but no. The first law of Kepler's law, what he told, that yes, that path in which the planets move around the sun is in the shape of ellipse, or we can say that the path is in the form of elliptical orbits. Got it? Okay. Here we can see in the figure 15 that the sun is at some foci F1 and now they are moving around the sun in an elliptical orbit. We are showing F1 and F2 which are said to be the foci of the elliptical path. Now we will see the Kepler's second law. Now what he states in the second law? That even each and every planet revolves around the sun and they revolve in the elliptical orbits according to the first law. Now they revolve around the sun in such a way that the line joining the planet to the sun. Now we will see the figure 16 that the line joining from the sun to the planet sweeps out equal area in equal intervals of time. From figure it is clear when the particle or the planet is farther from the sun, they are having the equal area, and when they are near to the sun, then they are sweeping equal area. What does it mean? When they are farther, they are sweeping small area, and when they are near to the sun, they will sweep more area. So the area will be equal. That what it means? When the planet moves faster when it is closer to the sun and moves slowly when it is farther from the sun. This will show that it joining the line of the planet to the sun sweeps over equal areas in equal interval of time. Okay. Have you got out the second law of Kepler's law of planetary motion? Okay. Let us move to the third law of planetary motion. Now, in the third law, Kepler states that the cube of the mean distance, what does the mean distance is? It is the distance from the sun to the planet, which is taken as r. So in this law he told that the cube of the mean distance of a planet from the sun is directly proportional to the square of time. Now let us consider the mean distance from the sun to the earth be r, and the time period or the time taken for the earth to move around the sun be capital T. Now according to the law, what we have said, that the cube of the mean distance r will be equal to the square of the time taken by it to move around the sun. So r cube will be directly proportional to t square. So we can take out the proportionality sign by giving a constant. Now if we want to write the t square in the downward of r cube, we can write r cube upon t square is equals to constant, where r is the mean distance of the planet from the sun and t is the time period of the planet which it takes to move around the sun. So here we can say that the Newton have given the law of gravitation which we have learned in the starting. We told that in the universe the planetary motion is whole due to the gravitation. Now Kepler shows the planetary motion of the earth, that the planets moves in the elliptical orbits. They move in the line joining from the sun will be equal in areas and will be equal in interval of times. Now the third law, what it tells, the cube of the mean distance between them will be equal to the square of the time period taken by the earth to revolve around the earth. Now we will move forward. Here the topic is free fall. What does this free fall means? If you are talking about gravity, we already told that it is acting towards the center of the earth, or it is the force of attraction which is acting towards the center of earth. So it will pull each and every object which is moving upward or the downward, but it will try to make that object pull towards the center, that is to the downward direction. So whether we are applying the force or not, whether the object is falling or not, but the body will try to make it pull towards the earth. So no force is acting on it. What we can say, without applying a force, or if the force is not acting on a body but it will move towards the downwards, that is towards the center of the earth. So some force is acting on it. Yes, it is the force which is acting towards the center of the earth, but we are not applying any force on that object. So the body will fall easily towards the downward direction. So what is free fall? The falling of a body or an object from the height towards the earth under the gravitational force, which means it is a gravitational pull or the force of attraction which is trying to make the object come downwards or to come towards the center of the earth. So as we are not applying any kind of force to that object to move, so it is a free falling body, or the object is said to be in the free fall. Here one example is shown, which is the bungee jumper. So the bungee jumper is falling down only under the gravitational force of earth. He is said to be in the free fall or a free falling body towards the earth. Okay, have you got it, children? Let us move to the next topic. Now what the acceleration means? It is a variation of velocity, means when the velocity is increased or the change in velocity is termed as acceleration. Now we have learned about the gravitational force which is acting on the object and led the object to pull towards the center of the earth. Now we will see that the velocity of the object can also be changed, and if the velocity is varying, then what term will come in? The acceleration, which is shown by the letter small a. Now we will see what the value of g will be, that is small g will be. And now we have already learned from the universal law of gravitation what capital F shows. It is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. So it came from the universal law of gravitation, where g is a gravitational constant, which can you see in the equation number 1. Okay, remember that equation number 1. Further we will use in between the derivation. Now next, we know that whenever a body is in motion, some force is acting on it. So the force exerted by the earth produces acceleration. Let us consider a stone is falling downwards. Now the force is acting on the stone will be due to the force of gravitation. So let us consider, let the force be F. This force exerted by the earth produces the acceleration in the stone. What does it mean? That whatever the velocity of the stone may be, but the velocity will increase when it comes downwards to the earth. So the earth produces acceleration in the stone, due to which the stone moved downwards. So we already know force is equals to mass into acceleration. From here we will derive the word acceleration. What it can be written as F upon m, which is force upon mass. Let us give this equation number 2. We will use this equation 1 and 2 together. By using the value of a, we will put the value of equation number 1, that is the value of F, that is F is equals to gmm upon r square. Here the two masses will be capital N and small m. But further, when we have already learned in the universal law of gravitation, we took m1 and m2. Okay, so here we are taking capital M and small m, and in during the force is equals to mass into acceleration, we are using the mass small m. So on dividing equations, we will get gmm upon r square into m. The m and m will cancel out each other. So what is remaining here? A is equals to gm upon r square. Now we already learned that the acceleration produced by the earth on that object is due to gravitation. So what we can call that acceleration? That it is acceleration due to gravity. So here the acceleration due to gravity comes in, which is represented by the letter small g. So in place of A, we can write it as small g, which is the acceleration due to gravity. Now we will see the expression of g, that what g represents? Capital G into m upon r square, where capital G is universal gravitational constant and capital M is mass of the earth, because mass of the earth, why? Because earth is exerting the force, right? Because the gravitational force is due to earth. And now radius of the earth, because the stone is falling under the action of earth's gravity, so it is the radius of earth. Now what will be the mathematical value of this g, that is the acceleration due to gravity? Now what we will do, we will put the value of capital G, which is 6.7 into 10 to the power minus 11 Newton meter per kg square. Earlier we have studied the unit of universal gravitational constant is Newton meter square per kg square. So we will put the value of capital G, and the mass of earth, which is 6 into 10 to the power 24 kgs. So we will put the value of the mass of the earth and the radius of the earth, which is 6.4 into 10 to the power 6 meter. According to the formula, what it is? That force into mass upon the r square. So force value is, that is the universal gravitational constant value is 6.7 into 10 to the power minus 11 into 6 into 10 to the power 24, and by calculating it we get g is equals to 9.8 meter per second square. What this unit shows? Because the acceleration due to gravity, and what is the unit of acceleration? Meter per second square. So acceleration due to gravitation will also have the same unit, that is meter per second square. So here we come to end of this chapter. We have learned the topics from the gravitation are, first of all we have learned about the introduction to gravitation, then we learned about the gravitational force, then universal law of gravitation, then acceleration due to gravity, which is denoted by letter small g, and universal gravitational constant is denoted by letters capital G, and the force acting on the object is denoted by letter capital F. And we have learned about free fall, what it means. When a body is under the force of gravitation, we never have to exert some other force or the external forces applied on any body. It is the force of gravitation which allows the body to move downwards, and this is called, and such a body which falls freely is known as freely falling body or the free fall. And here we come to an end of the class. Thank you, class. If you have any queries regarding this topic, you can contact me. Thank you.